Okay, good morning to all of you. In this class, we are going to discuss about uniform or rectangular distribution. With the help of last 3 to 4 classes, we have been discussed in detail about normal distribution. Uh, we discussed about the properties of normal distribution, characteristics of normal distribution, how the normal distribution is a limiting case for towards the binomial distribution. Then we have been discussed moment generating function of normal distribution, verification of mean and variance of normal distribution by considering moment generating function, moments of normal distribution about mean, and also we have been discussed two numericals, this one and this one in detail, and I given two numericals with hints, this one and this one. Hopefully you done these two numericals. Some other video I am going to prepare for these two numericals. It is very easy. It is very easy as compared with the two numericals whatever we have been discussed in our last class. Okay, so in our today class we are going to start to discuss about uniform or rectangular distribution. Okay, so let's start. So this is the definition of uniform distribution. A random variable x is said to have a continuous uniform or rectangular distribution over an interval AB, or that interval is nothing but from minus infinity to, that interval is your here a is greater than that of the minus infinity and a is less than that of the b, and b is your less than that of the plus infinity. That means you can say that any two number where a will be less than that of the b. It is telling that a always be less than that of the b. You can consider minus 2 3, you can consider 2 3. This is a value, b value. You can consider 0 and b value 5, like this. Any a value, any negative number you can consider, and b value also you can consider any negative, like this here. A value you can consider minus 5 and b value you can consider minus 2, like this. So whatever you are going to be consider a and b value, you have to remember that b always greater than that of the a. It's if its p.d.f is given by if x follows ab is equal to, or you can say if x such that ab equal to 1 by b minus a, if b less than that of the x, less than that of the b, otherwise 0, this is your so-called p.d.f of the normal or rectangular distribution. Here this is the graphical representation of this p.d.f, that along this axis, x axis, we have to take a and b value, and this is along y axis we have to consider p.d.f, or that is your fx. And here you can see in between a and b the value is a constant. So here you can found that in between a and b this value is a constant. So some book they have been written that 1 by k. So here b minus a is nothing but a constant. So you can write also 1 by k. Some other books they have been written, but here I suggest that you have to write down 1 by b minus a. So this is a constant value. So in between a to b, this function has the constant value, okay, or PDF has the constant value. Below A, above B, the fx is 0. Here is the definition also. In the definition you can find that one. And this representation also in this way can be represented that the random variable x follows the uniform distribution. Here capital U represents the uniform distribution in the range A, B. Okay. So if it is written like this, that means the random variable follows the uniform distribution or rectangular distribution. The range is A, B. So here you can see that as this area under this curve it looks like rectangular shape, so hence it is called as the rectangular distribution. Okay. Now we have to prove the PDF. Here the PDF is 1 by b minus a. Fx is your 1 by b minus a in the interval ab. So it has to be 1 in this region. In this region, if we are going to be integrate, the total area should be 1. So here a to b fx dx, we have to consider a to b fx is nothing but the probability density, that is your 1 by b minus a into dx. 1 by b minus a is the constant taken outside, and the integration of dx is nothing but x. A to b is the limit, so here a to b, so it will be, if we have to put upper and lower limit, we can get b minus a by b minus a is your 1. Here it has been proved. Okay, this is the PDF of this uniform or rectangular distribution. Now we are going to go for the moments or of uniform distribution. The rth moment about origin. Okay, here we have been considered about origin of a random variable x in general can be written as, that we know, mu r dash is nothing but expectation of x to the power r, which will be equal to minus infinity to plus infinity x to the power r into pdf into dx for your continuous distribution, and for your discrete distribution it will be summation over x to the power r into pmf, that we know. Okay, so as we are discussing the continuous distribution, so for this case mu r dash will be expectation of x to the power r is equal to, what is the range here? In general it has been written that minus infinity to plus infinity, but as the function fx exists in between a to b only, so we have to put a to b x to the power r fx dx. Okay, then now we have to find out mu 1 dash, or this is called the first moment about origin. You can write in the bracket. Okay, first moment about the origin, that is your a to b x into fx dx. So first moment about the origin, that means r equal to 1. So if r equal to 1, then that will be called as the first moment, because rth moment is nothing but x to the power r. So first moment will be r equal to 1, means x into 1 by b minus a into dx. Here b minus a is nothing but your pdf for this case. Okay, so here 1 by b minus a taken outside of the integration. Here x dx, if we are going to integrate, it will be x square by 2, and the limit is a to b. We have to just put a to b, and here upper limit, if we are going to put, it will be b square minus a square by 2 already is here. So this is in the form of b square minus a square, means it can be written as b plus a into b minus a. Already at the denominator b minus a is already there, so b minus a got cancelled, and we found b plus a or a plus b by 2. and this is first moment about the origin is nothing but your mean, right? So here we found the mean equal to a plus b by 2 or expectation of x. Okay, now we have to go for the second moment about the origin. Here I not written, you can write in the bracket. This mu21 is nothing but your second moment about origin, that is your r equal to 2. Okay, r equal to 2. A to b, if second moment, then r equal to 2, that means r to the power, sorry, x to the power 2 fx dx. So it will be x to the power 2 into fx is nothing but 1 by b minus a into dx. So b minus a constant taken outside, x square integration with respect to dx is nothing but x cube by 3 a to b. So put the limit, we can found that bq minus aq, here 1 by 3 b minus a into bq minus aq, so is equal to 1 by 3 into b minus a, and this bq minus aq can be written as b minus a into b square plus ab plus a square, that we know it is simple formula. And here b minus a got cancelled, and we found mu 1, that is your second moment about the origin, will be equal to 1 by 3 b square plus ab plus a square, nothing but expectation of x square. So now we have to find out the mean and variance of this UD, uniform distribution. So mean already we found here. Expectation of x is nothing but first moment equal to a plus b by 2, a plus b by 2, and variance is nothing but v, capital X will be equal to expectation of x square minus mean square or expectation of x whole square, right? Or you can say mu2 dash minus mu1 dash whole square. So mu2 dash we found this much, just I written here, and mu1 dash we found a plus b by 2. So here if we are going to consider whole square of this one, then it will be b plus a whole square by 4. So if we are going to be solve this one, or you are going to be add this one, then you are going to get b minus a square by 12. It is very easy, you can do by rough, no problem. So here we found variance equal to b minus a whole square by 12. Okay, see, watch carefully and write down the notes. Okay, these suppose moments of uniform distribution, sometimes asking in your exam, about 4 to 5 marks. Okay, mean and variance asking 2 to 3 marks. So write down the note perfectly, which is essential for your exam. Now we have to go for the moment generating function or m.g.f about origin of uniform distribution. Okay, in general we know the m.g.f about origin is m capital Xt equal to summation over x e to the power tx into pmf for your discrete random case, and for the continuous case it will be minus infinity to plus infinity e to the power tx into pdf. Instead of pmf we have to consider pdf, probability density function, into dx for the continuous random variable case that we know. For this case the mgf will be how much? Mxt will be equal to, here minus infinity to infinity is there, but here we have the pdf in between a to b, so we have to consider only the range a to b e to the power tx into the pdf is nothing but 1 by b minus a. You can see that the pdf is your 1 by b minus a, so 1 by b minus a into dx. So 1 by b minus a taken outside, a to b e to the tx into dx, very simple integration. So here e to the power tx integration is nothing but 1 by t into e to the power tx. A to b is your limit, you just put it, and we are going to get 1 by t into b minus a into put b into e to the power bt minus put a e to the at. So we found mxt equal to e to the power bt minus e to the at by t into b minus a, where t not to be 0. If we are going to consider t equal to 0, then mxt will be not to be defined, or it will be infinite. So here in this case particularly, t not to be 0. Now we have to verify the moments. Whatever we found, that is your first moment and second moment, will be this much and this much. In this way, from by using moment generating function also, we are going to get these two value. Okay, so first moment and second moment we are going to verify uh, by using moment generating function. Verification of moments by using moment generating function, it is very easy. mxt we found e to the power bt minus e to the power at by t into b minus a. Here you can see t is at the denominator. So if we are going to consider t equal to 0, then mxt not to be defined. So we have to expand these two exponential functions. So here we can do that 1 by b minus a into 1 by t is there, and e to the power bt, if we are going to expand, that will be 1 plus bt plus b square t square by 2 factorial. I have to zoom somewhat. Okay, b square t square by 2 factorial plus bq2 tq by 3 factorial plus b4 t4 by 4 factorial, and so on, and then minus e to the power at is there. So it will be 1 plus at plus a square t square by 2 factorial plus aq tq by 3 factorial plus a4 t4 by 4 factorial plus so on. Now here 1 by b minus a is there. Now I am going to multiply 1 by 2 t with each term. Okay, and also here minus also we are going to multiply these terms with these terms. So this is 1 by t into 1, this will be 1 by t. Here bt by t will be b square t square by 2 factorial into 1 by t will be how much? B square t by 2 factorial, bq tq by 3 factorial into 1 by t. This will be bq t square by 3 factorial, b4 t4 by 4 factorial into 1 by t will be b4 tq by 4 factorial, and so on. Okay, and consider this one. This one here, it will be minus 1 into 1 by t. It will be minus 1 by t, right? 80 into 1 by t, minus is there, so it will be minus a, right? Here a square t square by 2 factorial into 1 by t, minus is there, minus a square t by 2 factorial, likewise minus aq t square by 3 factorial. We can get next term is minus a4 tq by 4 factorial, and so on, right? Now here mxt we found how much? 1 by ba, 1 by b minus a, this one 1 by b minus a. Here 1 by t minus 1 by t got cancelled, and we are going to get b minus a. And here you can get that here b square t by 2 factorial minus a square t by 2 factorial. We can write b square minus a square into t by 2 factorial. Okay, here you can see that t square by 3 factorial is there. This is bq t square by 3 factorial. This is minus aq t square by 3 factorial. So we can write that bq minus aq by 3 factorial into t square. Okay, and likewise by considering these two terms, we can write b4 b to the 4 minus a to the 4 by 4 factorial into tq, right, and so on. Because as we are considering as we are trying to find out only first and second moment, I not considered the higher order terms. So here 1 by b minus a, I am going to divide with each terms, right? What I am going to get, see, whenever 1 by b minus a is going to or b minus a is going to divide with this term, it will be 1. This will be how much? Here it is b square minus a square, means b plus a into b minus a. So b minus a got cancelled, we are going to get b plus a. Here bq plus aq is there, so bq plus aq can be written as this one, b minus a into b square plus ab into b square plus ab plus a square. This much can be written. So if will be divide, if I am going to divide with this by b minus a, so b minus a will be got cancelled, and we are going to get this value. Okay, and I am not going to be consider higher order. because as I'm trying to find out the first and second moment. So by dividing b minus a with this and this, we found that 1 plus t by 1 factorial, right, into b plus a by 2. Here you can see b minus a by b minus a will be 1. Then here you can see that t by 2 factorial is there. So if I am divide b minus a, then b plus a, b minus a is nothing but b square minus a square. So b minus a got cancelled. We are going to get b plus a, and here t by 2 factorial can be written as, this t by 2 factorial can be written as t by 1 factorial into 1 by 2. Yes or no? Likewise, BQ AQ is nothing but how much? B minus a, B square plus AB plus A square, right? So this BQ AQ is nothing but B minus a into B square plus AB plus A square. If you want, you can write another step. I omitted that one. If you want, you can write this step. So divide by b minus a. So b minus a got cancelled. We are going to get b square plus ab plus a square divided by here 3 factorial. I can write that 2 factorial into 3. I can write 2 factorial into 3. Okay, so same thing I have been written over here. The first term is your 1, the plus t by 1 factorial. Here you can see t by 1 factorial into 1 by 2. Okay, that means t by 2 factorial can be written as t by 1 factorial into 1 by 2. That means t by 1 factorial into b plus a by 2 plus here t square by 3 factorial can be written as t square by 2 factorial t square by 2 factorial into t square by 2 factorial into 3. So here t square by 2 factorial into 3, and numerator will be how much? B square plus ab plus a square by cancelling b minus a and this b minus a, right? So here, and other higher order terms I am not considering here. So now finally I found that mxt is this one. Okay, here you can see that there is no t term at the denominator. Okay, I have been transformed this structure of this mxt to this one. Here in this structure of the mxt, you have t at the denominator, which is difficult to us to put t equal to 0, but here t, there is no t at the denominator. Right, now we have to find out from the mxt the moments. We know the two methods, coefficient method and derivative method. You can see the coefficient of t by 1 factorial will be nothing but your first moment, right? So here t by 1 factorial coefficient is nothing but how much? B plus a by 2. That is your nothing but ex. Already we found in this way. Okay, ex, this is your a plus b by 2, and here also same, b plus a by 2, nothing but a plus b by 2. That is your first moment, has been verified. Now we are going to consider the second moment. Whatever we found, that is going to be match or not. See, t square by 2 factorial coefficient is nothing but this one, b square plus ab plus a square by 3, exactly matched whatever we found here, right? So this is your mu2 dash or second moment about the origin or expectation of x square, has been verified in this way, or you are going to consider the derivative way. First derivative, we know that rth moment can be found by dr mxt by dtr at t equal to 0. These things we know very well. So now we are going to find out mu 1 dash means first moment. First moment means first derivative of mxt with respect to t. Then we have to put t equal to 0. Then first you do the derivative of this one. Then what you are going to found first derivative will be 0. First term will be 0. Second term will be how much? This will be b plus a by 2, and third term will be how much? 2t by 2 factorial into b square plus ab plus a square by 3 factorial, and so on. You can see your third term contains t, so obviously higher term also contains t, so plus terms containing t. Now after first derivative, when I am going to put t equal to 0, then except this term all other terms will be 0. So here I written that first derivative of mxt with respect to t at t equal to 0 means first derivative is nothing but b plus a by 2, then plus t terms. T terms. So if we are going to consider t equal to 0, then these terms whatever we have uh, plus these terms is going to be 0, and finally we are going to find out b plus a by 2, that is your first moment or expectation of x, right? Now we are going to go for the second moment, that is your mu2 dash. Mu2 dash means double derivative of mxt with respect to t, that is your, here I written, forgot to write, d square mxt by dt square, okay, dt square at t equal to 0, right? So we have to consider the double derivative of mxt. Here you can see that first derivative already we have been done. Then again if we are going to consider the second derivative, what we are going to get, this term is a constant, we are going to get the 0. Then this term here 2 got cancel, the derivative with respect to t, if I am going to consider the for this term, we are going to get how much, b square plus ab plus a square by here not 3 factorial, this is 3 because t by 2 factorial, t here this one first derivative means 2t by 2 factorial, this 3, okay, so 3, right, plus whatever the term we are going to get after that also contain t terms, okay. So then if we are going to put t equal to 0, these terms whatever we have here after the second derivative of moment generating function, these terms will be how much, will be 0, whenever we are going to consider t equal to 0, right? So finally we found that b square plus ab plus a square by 3. So we found b square plus ab plus a square by 3, that is nothing but your second moment about the origin, or ex square whatever we found in this way, okay. Here we have been verified the moments with the help of m.g.f. Now we are going to go for the few numericals uh, on uniform distribution. Here this is the first question, that if x is a random variable which is uniformly distributed having mean 1 and variance 4 by 3, find probability x less than 0. So how we are going to do this? See, for ud means here in short I have been written uniform distribution as ud. We know that mean equal to a plus b by 2 equal to 1, whatever given in the question. That implies a plus b equal to 2. Let this is your equation number 1. And variance given that 4 by 3. For this case variance, how much we found, b minus a by 12, b minus a whole square by 12. You can see just now we found the variance of the uniform distribution is your nothing but b minus a square by 12. So we have to consider that one, that is your b minus a whole square by 12 equal to 4 by 3, and that implies b minus a whole square equal to 16, b minus a equal to plus or minus 4. So now here what we are going to be consider, right? Here now we are going to solve 1 and 2. 1 and 2 you can solve. Here you can found that suppose I am going to consider a plus b equal to 2 and b minus a equal to plus 4, right? If I add it, then b we are going to get how much, here you can see 2b equal to 3 and b 6, b equal to 3. And if b equal to 3, here you can b equal to 3, then just put b equal to 3 here, then a equal to -1. So here we can found that a is less than that of the b. Okay, but if we are going to consider that b minus a equal to -4, then what is going to happen? You can see a plus b equal to 2, and b minus a we have been considered as -4, suppose. Then what we are going to do, that here you can see, just add, we are going to get b to b equal to -2 and b equal to -1, and if this b equal to -1, if I will put here, then a equal to 3. But in for this case, that if we are going to consider b minus a equal to -4, then we can found a is greater than b, but actually we have to consider a less than that of the b. So here these two value we have to consider, a equal to -1 and b equal to 3. That means b minus a equal to +4 we have to consider. So here we are going to get that 1 by b minus a is nothing but 1 by 3 minus of -1 equal to 1 by 4. So pdf of this distribution we found 1 by 4. Now probability x less than 0 will be how much? Less than 0 means here you can see the maximum limit b equal to how much? B equal to your 3, and minimum limit is your -1. So we are going to consider below 0. So 0 will be here somewhere. So below 0 means it will be up to, it will move up to -1. So -1 to 0, 1 by x dx, 1 by 4 dx, 1 by 4 taken outside, dx integration x limit -1 to 0, then we are going to get 1 by 4 is the answer. Okay, now second question is your, so that for a uniform distribution fx are already given here, pdf of a uniform distribution given that 1 by 2a for the limit or the range -a to +a. Okay, -a to +a has been given, and you have to show that for this distribution m.g.f about the origin is sin h at by at. Then also you have to show that moments of even order are given mu 2n dash equal to a to the power 2n by 2n plus 1. Okay, so we know that mgf, how we are going to solve this first question, that mgf we have to find about the origin will be this much. So we know that the mgf of ud in the interval a to b is nothing but a to b e to the power tx into fx dx. Here it is given that fx equal to 1 by 2a. So you just put instead of fx 1 by 2a minus a to a e to the minus e to the tx into 1 by 2a into dx, because the fx exist in between -a to +a. So the limit we are going to consider -a to +a e to the power tx into 1 by 2a into dx. 1 by 2 is constant taken outside, e to the power tx. Now e to the power tx integration, that means e to the tx by t, -a to a, -a to limit a, we have been substituted the limit. Now then we are going to get 1 by 2at, 1 by 2at, a just put over here, it will be e to the power at minus of e to the -at. Very simple. So here we found mxt equal to how much? 1 by 80 is there, 1 by 80 into e to the power 80 minus e to the power -80 by 2. Okay, so this is nothing but your sin ht that we know. So mxt we found 1 by 80 into sin h80. So hence it has been proved. Now we are going to be so that this will be this, that means moments of even order about the origin will be a to the power 2n by 2n plus 1. See how we are going to do this. Just now we found mxt is how much? Mxt moment generating function is this one, 1 by 280 or 1 this one. Okay, so same thing I have been written in the next page, that mxt we found mxt equal to 1 by 280 into e to the 80 minus e to the -80, that is your sin h80 by 80, right? So I am just, and here t not to be 0, we could not put the t equal to 0. So from the mxt, if we want to find out the moments of rth moment, so we have to transform, or we have to change this structure to another structure where the t or t term not to be found at the denominator. So what we are going to do, we have to expand e to the power at and e to the power minus 80, e to the power 80 and e to the power minus 80. Okay, or if you remember the sin ht expansion, also you can consider the expansion of sin ht. So here I am considering e to the power 80 expansion, e to the power minus 80 expansion. So 1 by 280 is there, e to the power 80 is nothing but 1 plus 80 by 1 factorial, a square t square by 2 factorial, a q t q by 3 factorial, and so on, minus e to the power minus 80 expansion will be nothing but 1 plus minus 80 by 1 factorial plus minus 80 by 80 square by 2 factorial plus minus 80 cube by 3 factorial, and so on, right? So here 1 by 280, this much I have written as such, minus this will be minus 1. Here you can see minus 80 minus plus 80 by 1 factorial. Here this will be plus because its power is 2. This will be plus and minus, so minus a square t square by 2 factorial. This is 80q. If we are going to consider the power is 3, so it will be negative, and here negative will be positive aq tq by 3 factorial, and so on, right? Simple, very simple. Here you can see that plus minus got cancelled, all odd order terms are going to be cancelled out. See, uh, sorry, all even order terms are going to be cancelled out. See here, 1 got cancelled, a square t square by 2 factorial minus a square t square by 2 factorial, it will be cancelled out. Likewise, if we are going to consider higher order, you can find that a to the 4 t to the 4 by 4 factorial will be cancelled with another minus term, right? So here we found 1 by 280, 80 by 1 factorial, 80 by 1 factorial, 280 by 1 factorial, aq by 3 factorial, aq by 3 factorial. So 2 aq by 3 factorial. Then likewise next term you can found 2a to the power 5 t to the power 5 by 5 factorial, and so on. Here 280 is there, just divide with each term. We are going to get 1 plus here a t is there, right? 2 got cancelled, a t will be got cancelled, means a square t square by 3 factorial. Next term will be a to the 4 t to the 4 by 5 factorial, and so on. And what we are going to get in general, here you can see 4 divided by 5 factorial. So in general we can write a to the power 2n into t to the power 2n by 2n plus 1 factorial plus so on, right? So here you can see 1 plus a square t square by 3 factorial, you can write 3 into 2 factorial, a to the power 4 t to the power 4 can be written as 5 into 4 factorial, and so on. This denominator easily can be written as 2n plus 1 into 2n factorial, right? So a to the power 2n to t to the power 2n by 2n plus 1 into 2n minus 1 factorial. Now for the first moment we know that the coefficient of t by 1 factorial is nothing but the first moment. You just search that in this series, are you getting t by 1 factorial term? There is no t by 1 factorial term. Likewise, tq by 3 factorial term, coefficient of tq by 3 factorial, that is belongs to your mu 3 dash, but you are not going to get tq by 3 factorial. That means odd power terms you are not going to get in this series. So hence for odd order about origin is 0. That means therefore not present. That means t by 1 factorial term is not present. So first moment will be about the origin will be 0. Likewise, third moment, fifth moment, all moments for n equal to 0, 1, 2, 3 like that. See here in generalized it has been written 2n plus 1 dash moment. That means if we have to put 0, 1, 1 it will be 3, third moment to fifth moment and seventh moment, all moments for odd order about the origin are 0. Not right, are 0, value are 0. So but coefficient of t to the power 2n by 2n factorial, t to the power 2n by 2n factorial is how much? A to the 2n by 2n plus 1, a to the 2n by 2n plus 1. So this we intend to prove initially, and here we have been proved, that is your 2n plus 1 dash equal to a to the n by 2n plus 1. Here in the question this much we have to prove, and here uh, it has been given that we have to prove this one, and here we have been proved. Okay, so here we have been completed all the contents regarding your uniform distribution as per your BSc syllabus, and we have been also done two numericals. Likewise you can attempt other numericals. If you have doubt you can ask me, no problem. And I suggest again and again that carefully you have to watch the video and write down the note, which is most essential for your exam point of view, right? And ready for the next class. In our next class we are going to discuss about gamma distribution. So thank you so much for watching this video. Thank you.